This is SpaceTime Series 29, Episode 40, for broadcast on the 3rd of April 2026. Coming up on SpaceTime, using archaeology to study the history of galaxies like the Milky Way, Europe re-establishes contact with its lost Proba 3 spacecraft, and using blue-green algae to grow food on the red planet Mars. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Astronomers have for the first time used what they're calling galactic archaeology to trace the history of a galaxy beyond our own galaxy, the Milky Way. The findings, reported in the journal Nature Astronomy, demonstrate a new way to reconstruct the evolution of distant galaxies using their detailed chemical fingerprints. The study's lead author, Lisa Cooley from the Harvard-Smithsonian Center for Astrophysics, says it's the first time that a chemical archaeology method has been used with such fine detail outside our solar system. She says the work will help astronomers better understand how we got here, how our own Milky Way galaxy formed, and why we ended up breathing oxygen, the very same oxygen we're breathing right now. Using data from the Typhoon survey at the Las Campanas Observatory, the authors examined the nearby spiral galaxy called NGC 1365, also known as the Propeller Galaxy or the Great Bard Spiral. Located some 56 million light-years away in the constellation Fornax, the galaxy's wide disk shape is oriented so we see it face-on from Earth. The authors achieved resolution sharp enough to separate and study individual star-forming molecular gas and dust clouds in the galaxy. When they're young, hot stars shine brightly in ultraviolet, and that intense light can excite nearby gases. Each element in that gas, such as oxygen, can then be identified by its spectral signature as a series of bright, narrow lines of light. The centres of galaxies usually have more heavy elements, including oxygen, while their outer parts have less. The oxygen pattern is shaped by several factors, including where the stars formed and exploded as supernovae, how gas flowed in or out of the galaxy, and past mergers with other galaxies. By measuring how the oxygen patterns changed across the galaxy and then comparing that to state-of-the-art computer galaxy simulations, the authors were able to see how the galaxy grew and merged with other galaxies over its 12 billion-year cosmic history. The computer simulations track the motion of gas, star formation, black holes, and chemical evolution in galaxy from shortly after the Big Bang right through to the present day. The authors searched through simulations of some 20,000 galaxies, eventually finding one that closely matched NGC 1365's observed properties. And from this, they were able to infer the galaxy's likely merger and growth history. The authors found that NGC 1365's central region formed early in the galaxy's history and developed a large amount of oxygen. Meanwhile, the gas further out built up over 12 billion years through collisions with smaller dwarf galaxies. The gas in the outer spiral arms of the galaxy probably formed relatively late, over the last few billion years, and was also fed by gas and stars from merging dwarf galaxies. The findings confirm that the astronomical processes astronomers model on computers really do represent how galaxies like NGC 1365 evolve over billions of years. Overall, the study shows that NGC 1365 began as a relatively small galaxy and slowly grew into a giant spiral through multiple mergers with other small dwarf galaxies. By studying galaxies like NGC 1365, which bears similarities to our own Milky Way galaxy, astronomers will be able to gain an insight into how typical or unusual our Milky Way galaxy is, and the different pathways galaxies can take to reach their current states. This is SpaceTime. Still to come, Europe re-establishes contact with its lost Proba 3 spacecraft, and using blue-green algae to grow food on the red planet Mars. All that and more still to come on SpaceTime. The European Space Agency has successfully re-established contact with one of the spacecraft in its Proba 3 mission. Mission managers lost contact with the probe a month ago when it mysteriously went silent. The twin Proba 3 spacecraft were launched back in 2024 on a 2-year mission to study the Sun's little understood outer atmosphere, the corona. The corona is several million kilometres thick, but it's normally hidden by the bright glare coming from the Sun. It's usually only able to be studied for a few minutes at a time when the Earth experiences a total solar eclipse, during which time the Moon passes directly in front of the Sun, blocking out the sunlight and exposing the milky white corona in all its glory. While total eclipses on Earth last just a few minutes and only occur a couple of times a year, Proba 3 was capable of securing 10 to 12 hours of observations every week over its 2-year mission. See, the two probes are designed to fly together in formation, but they have to be very precise, allowing them to artificially simulate a solar eclipse. One of the satellites is equipped with a 1.4-metre sunshade that directly blocks out the Sun from its sister spacecraft, which is fitted with cameras. By flying in precise formation 60,000 kilometres above the Earth, with one spacecraft hiding the Sun's glare from the other, scientists can study the corona in detail. However, on February the 14th, the second spacecraft, one which has the crucial chronograph instrument, suddenly lost communications. And this triggered a cascade reaction, causing it to lose orientation, resulting in its solar array panel facing away from the Sun, draining the batteries. The spacecraft then entered a survival mode, and it's been silently tumbling through space ever since. The European Space Agency's director, Josef Aschenbacher, says by some miracle, contact with the wayward spacecraft was restored. The other spacecraft, the one with the shield, had been following and observing its lost twin. Aschenbacher says as the faulty spacecraft tumbled, its solar panel must have positioned itself just right for a few moments to grab enough sunlight to generate enough power to allow communications to be restored, and that gave ESA mission managers the time they needed to send up new instructions. The good news is the spacecraft's solar panels are now facing the Sun, allowing it to recharge its batteries. Meanwhile, mission managers are now trying to determine what went wrong in the first place, and they're carrying out tests to find out how much damage has been done. This is SpaceTime. Still to come, using blue-green algae to grow food on the red planet Mars, and later in the science report, a new study warns that abstinence could affect sperm quality. All that and more still to come on SpaceTime. Scientists have used a cyanobacteria-based fertilizer to grow food in a simulated Martian environment. When humans eventually undertake that long, arduous journey to the red planet, they'll need to take enough food, water and air with them for what's likely to be a 2-year mission, a logistical nightmare. Or alternatively, they'll need to be self-sufficient and grow their own food along the way and when they arrive on the Martian surface. Now, scientists at the University of Bremen and the German Aerospace Centre DLR have developed a fertilizer which can be produced solely with Martian resources. The fertilizer is based on cyanobacteria, also known as blue-green algae. A report in the Chemical Engineering Journal claims blue-green algae has several properties that make it especially suitable for use on the red planet. The algae uses carbon dioxide from the Martian atmosphere to produce oxygen and extract important nutrients directly from the Martian soil. The cyanobacteria were cultivated with simulated Martian resources, including an artificially produced regolith that mimics Martian dust. The cyanobacteria are then converted into a nutrient-rich product. This is done by microbes, using an anaerobic fermentation process without any oxygen and using only materials which are potentially already available on the Martian surface. The authors were interested in investigating how to optimize this fermentation process. They found that heating the biomass before processing led to faster decomposition, and an operating temperature of 35 degrees Celsius proved to be ideal for the fermentation process. Also, the ratio between the amount of biomass used and the amount of ammonium yield was important, as it informs how much cyanobacterial biomass needs to be added to get the right concentration of ammonium in the fertilizer. A Mars dust simulant was used as the main source of mineral nutrients, showing that the fermentation can be done using local Martian resources alone. The resulting fertilizer was used to grow duckweed, a fast-growing protein-rich aquatic plant that's been consumed as a food across Southeast Asia for centuries. From just 1 gram of dry cyanobacteria, 27 grams of fresh edible plant biomass was obtained. One of the study's authors, Tiago Ramello from the University of Bremen, says the self-sufficiency aspect's important to make future Mars settlements sustainable. But he says cyanobacteria also has great potential beyond space missions. It grows quickly, it's nutrient-rich, it's easy to cultivate, and it's completely edible. It's already approved as a food in the European Union, and is considered a contender for a sustainable superfood of the future, both here on Earth and in space. In addition to food production, the system offers another advantage. The process produces methane, which can then be used as an energy source. Jasmine Plantner from ZAM, the Centre for Applied Space Technology and Microgravity, is speaking here with ZAM researcher Tiago Ramello from the University of Bremen.
How can we grow food on Mars using only local resources? Growing food on Mars sounds like science fiction, but you are working on making it reality. Can you tell us what the big challenge is?
Yes, so the main challenge is that we cannot ship items from Earth. That means that we have to produce everything on site, including food, fertilizer, and water. And that's where our research comes in.
You're using cyanobacteria. Why are they so interesting for Mars?
So cyanobacteria are incredibly versatile and resilient. In addition, they are capable of fixing carbon dioxide and nitrogen from the atmosphere, as well as extracting mineral nutrients from the regolith, which is basically the Martian soil. In addition to that, they are capable of producing oxygen, which is super useful because you can give it to astronauts and create a closed-loop ecosystem.
And once you have grown the cyanobacteria, how do you turn them into fertilizer?
We use a process called anaerobic digestion, which basically means that we use a community of microorganisms that work together to break down the biomass and convert it into a nutrient-rich liquid that's called a digestate. This digestate contains ammonium as well as other important nutrients for plants to grow, and it's just made from cyanobacterial biomass and the Martian regolith, which we use a simulant of. As a bonus, which is really cool, is that this process produces also methane, which can be used as a fuel on Mars.
And you tested different conditions to improve the process, right?
Exactly. So we looked into the pre-processing of the biomass, the operational temperature, and also the biomass concentration in order to make the process as efficient as possible and get as much nutrients as we could possibly for the plants. One important thing that we defined was the concentration of biomass that we needed to add in order to get the amount of ammonium that is suitable for a plant fertilizer afterwards.
With simulated Martian soil, how did that fit into the process?
Again, we want to use as much resources on Mars as possible, and for mineral nutrients, that means using the regolith that's available there. And so for this study, we used the Martian regolith simulant, and we tried to understand what's the best way to deliver its nutrients into the anaerobic digestion. So we found that instead of providing it directly into culture, it's best to first extract the nutrients and then giving it to the anaerobic digestion. When you add just a tiny bit of trace elements, then you get the best nutrient recovery for your fertilizer.
Now the big question. Does this digestate actually support plant growth?
So yes, the great news is that we are actually capable of growing duckweed on the fertilizer that we produced. Duckweed is extremely interesting because it's fast growing and it has a high nutritional value, which makes it a perfect crop for Mars. In addition, it's also already approved for consumption here in the EU, and we are able to produce 27 grams of fresh duckweed biomass from just 1 gram of cyanobacterial dry biomass.
And what does this mean for future Mars missions?
So this basically shows that we can potentially create self-sufficient ecosystems on Mars, which relies solely on the resources that are found there.
Basically, you're building a circular ecosystem for space.
Exactly. So basically, microorganisms and plants work together in order to support human life far away from Earth.
And what's next for your research?
Yeah, so we're looking into scaling the system, testing it under more Mars-relevant conditions, as well as looking at other crops that we can test the fertilizer on. Overall, the main goal is that we make Martian habitats as independent from Earth as possible.
That's Jasmine Plantner from ZAM, the Centre for Applied Space Technology and Microgravity, speaking with ZAM research scientist Tiago Ramello from the University of Bremen. And this is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with the Science Report. A new study warns that abstinence could affect sperm quality. A report in the journal Proceedings B looked at over 150 studies on semen storage in both humans and other animal species, finding sperm performance might deteriorate slightly after a period of abstinence. They found storage through sexual abstinence was linked to a small but statistically meaningful decline in sperm performance that's likely due to increased DNA damage and oxidative stress. The authors say their findings could provide information to help fertility clinics produce better quality embryos, as well as helping researchers who are breeding animals in captivity. Scientists have recovered ancient Pinot Noir grape pips, suggesting the famous tipple may have been a favourite in France for almost 600 years. A report in the journal Nature Communications analysed the DNA of ancient grape pits found across the country, discovering one that was identical to the modern red grape variety. The study shows that grapes have been deliberately grown in France since the Iron Age around 2,500 years ago, and that different varieties were introduced during Roman times due to trading cuttings and seeds between Europe, the Middle East and Asia. The authors say this showed the long history of growing grapes in Europe, and that some varieties, like Pinot Noir, have been continually grown for hundreds of years. A new study shows that many birds are boozing on the human equivalent of a beer a day. The findings, reported in the Journal of the Royal Society Open Science, show that many flowers have nectar that contains tiny amounts of alcohol, which, when consumed by birds and bees, is equivalent to a human drinking a glass of beer every day. The study measured the exact concentrations of alcohol that result from fermentation by yeasts living within the nectar. The authors found that 26 of the 29 species of flower they tested had alcohol in at least one sample, and for a single species, around half of all samples contained alcohol. When they looked at what the levels of alcohol might mean for the birds and bees pollinating those flowers, they found that hummingbirds and sunbirds consumed a daily dosage equivalent to 1.3 to 1.9 glasses of beer. Cheers! The UFO documentary, The Age of Disclosure, has been given a special screening on Capitol Hill. UFO fans have hailed the movie as a game-changer in public attitudes towards UFOs, ending the culture of silence around claims once dismissed as the preserve of conspiracy theorists and crackpots. However, critics are pointing out that while the doco has a lot of stories, it contains very few actually verifiable facts. The skeptic's Tim Mendham says it's really a case of same old, same old.
Age of Disclosure is the latest super-duper revelation documentary on UFOs, or UAPs as we call them these days, in which it shows that there is a major cover-up. Governments, they have the craft, they have the aliens, interviews a number of people. It's a result of what's becoming a bit of a boom industry, which is the UAP revelation industry. There's a lot of stuff that's come up in the last few years, especially when they start presenting to Congress, which actually says something about congressmen. These people who used to work for various government organisations now, talking about stuff they can't reveal is what it comes down to. We'd like to tell you, but we can't give you details. I was told. By whom? Can't tell you. There are craft buried in the ground. Where are they? Can't tell you. So this follows the same trend. It's a well-made documentary. It's the people I've spoken to or heard about who have seen it and who are well-informed in the field say there's nothing new, right? In fact, they say there's other documentaries which treat some of these particular events or claims in more detail than is in this particular feature.
My gosh, next thing you'll be telling me there was no Magic 12.
It has the usual suspect. A lot of the people are the same people who keep cropping up across all the various programs. A lot of the films and the documentary stuff are the same fuzzy films of things that are supposed to be UFOs. Most of the time are not. It's a classic case of one of the people who was showing up some photos of UFOs and one of them turned out to be a chandelier. But never mind. It's all about the revelation is coming. There's going to be the announcement. The president or someone is going to say, yep, here's the good oil. Here's what's really happening any day now. And they've been saying this since about 1947. And you can go back through all the old
the good old days when there were frisbees and hubcaps that were being
used. Well, that's exactly right. Yeah, I think a lot of them still are, actually, quite frankly. Or balloons. Balloons are the big thing these days. But they've been saying this for years. And we've had things saying, just recently, 24 is the year of the big revelation, and then 25, and then now it's 26. 27 is being raised. And they're going to raise 30. Fine, but do it. It's the problem. Don't just talk about it. All these things just talk about it, and they present the same evidence, in quote, which has been debunked well and truly. 90-odd% of cases, the other ones are the unidentified, which don't mean they're alien, they just don't know. And there's nothing new, nothing really new in this Age of Disclosure documentary, and there's nothing really been new on the various news reports and things that have been said for the last few years. One person, Australian journalist Ross Coulthard, Walkley Award winner, was saying that he has evidence of large spacecraft buried underground, huge spacecraft, like enormous football field size things, with buildings put on top of it. And you ask him, where? And he said, well, I can't tell you. And he said, well...
Come on, that was the theme from Independence Day.
Yeah, but I mean, you tend to say, listen, Ross, and everybody else who makes these claims, where's your evidence? Please. Yeah, I'd love to see it. It's not going to shock the world. There's not going to be major upset. People are interested, very interested in these things at the moment, but they're getting frustrated because it's the same old non-evidence being put forward, the same old talking heads coming out and making their particular cases. It's depressing. I'd like to see something more definite. You know, I mean, the photos are still as rubbish as they have been for the last 80 years. The anecdotes are still sort of wobbly. All the evidence is very, very more than questionable, I think, in the vast majority of cases. And this is just one more example of it. One of the classic things about this is explaining why the evidence is so poor, why we can't photograph UFOs clearly, is because they're in a space-time quantum bubble that distorts all the light around them.
As soon as you use the word quantum, automatically...
I like it when they use the word quantum. Yeah. I feel an explanation is not complete unless they use the word quantum. And honestly, this is just... They're desperate. They're desperate to try and explain why their evidence is such rubbish. So until they actually come up with decent evidence, I think they'll say, yep, let's wait.
That's the Skeptic's Tim Mindham, and this is Space Time. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from SpaceTimeWithStuartGarry.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies. Or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to SpaceTimeWithStuartGarry.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.